All right, guys, section 8.2, multiplying a polynomial by a monomial. So previously we multiplied monomials. Now we're going to multiply a polynomial by a monomial and solve equations involving the products of monomials and polynomials. So some new vocab. We've already talked previously about monomial, so we're going to keep bringing that up, and polynomial as well. Remember, mono means one, so a monomial is a one-termed polynomial. Poly means many, so polynomial means more than one term. So to find the product of a polynomial and monomial, you can use the distributive property, which we've previously used the distributive property multiple times. So I want to find the product of negative 3x squared and the quantity 7x squared minus x plus 4. Well, one method is the horizontal method, and this is by far my favorite method. So what you're going to do essentially is distribute the negative 3x squared to all three terms. Okay? So you have negative 3x squared times the 7x squared times the negative x times the 4. Okay, so when you multiply monomials together, remember you multiply the constants and add exponents for like bases. So this one would become negative 21x to the 4th. This one you have the negative times the negative 3, which gives you minus the negative 3. X squared times x will give you x cubed. And here negative 3 times the 4 gives you negative 12, and the x squared just stays. And you subtract the negative here, or negative times a negative, you can write it as addition. And when you add a negative, you could write that as subtraction there. So there's your final answer. The vertical method, this is similar to if you did like a one-digit number times a three-digit number. If you had 322 times 7, remember you did 7 times 2, which is 14, carry the 1. 7 times 2 plus 1 is 15, carry the 1. 3 times 7 is 21, plus 1 is 22, and you got your answer there. Well, similarly, you're going to do the 3x squared times the 4, 3x squared times the negative x, negative 3x squared times the 7x. Okay, and you get the answer there. I prefer the horizontal method personally, so a lot of the problems here we're going to do horizontally. I just think the vertical method doesn't lend itself whenever we get into more complicated problems. So here's 2 for you to try. Go ahead and pause the video. All right, we're back. So the first one, you distribute the negative 5a squared, you get negative 20a to the 4th. To the 2a, you would get plus 10a cubed. Don't forget, when the exponent on the a, when there's not an exponent, it's understood to be a 1. So 2 plus 1 give you an exponent of 3, times a negative 7 give you negative 35a squared. All right, there we go for that one. The second one, negative 6d cubed times 3d to the 4th would be negative 18d to the 7th. Multiply here. Don't forget here you have a negative times a negative, which would give you a positive 12d to the 6th. Same thing here, you would have plus 6d. Remember, this exponent's understood to be 1, so it'd be d to the 4th. Plus 6 times 9 is 54, so actually let me write that as minus 54d cubed. Alrighty, cool stuff. All right, we can use this same method more than once to simplify larger expressions. So here's one where you have a monomial times a binomial minus a monomial times another binomial. So in this case, same thing, but you're just going to distribute the 2p to the first set of parentheses. In here, since it's minus 5, distribute the minus with it, take the sign with the number, to the second set of parentheses. So you'd have 2p times the negative 4p squared and 2p times the 5p right here. And then the negative 5 times the 2p squared here and the negative 5 times the 20 here. Multiplying those, you get negative 8p cubed plus 10p squared minus 10p squared plus or minus 100. Also, notice you have some like terms here, so you want to completely simplify, and those would actually cancel each other out. You don't really need to write this step. You can just see that 10p squared minus 10p squared cancel each other out, and you'd end up with negative 8p cubed minus 100. All right, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So 2a, the 3 distributes to the first set of parentheses, giving you 15x squared plus 6x minus 12. And the minus x distributes to the second set of parentheses, giving you negative 7x cubed minus 2x squared plus 3x. Now, when you simplify, you combine like terms and you write it in standard form. Notice the highest exponent is going to be third power. That's going to go first. Take the sign with the numbers, set negative 7x cubed. Then you have 15x squared minus 2x squared, which would give you plus 13x squared. Then you have a 6x and a 3x, which would give you plus 9x, minus the 12 at the end. Okay, so negative 7x cubed plus 13x squared plus 9x minus 12. Let me erase that and do the next one. So distribute the 15t to both terms. So you would have 150 y cubed t to the 6th plus 75 y squared t squared. Then, then distribute the negative 2y. So you'd be negative 2y squared t squared minus 8y cubed. So now we got to look for any like terms. So there are no other terms with a y cubed t to the 6th. You have a 75y squared t squared and a minus 2y squared t squared there as well. So those are going to combine to give you 73. So your answer would be 150 y cubed t to the 6th. These two combine to give you plus 73 y squared t squared. Remember, when you combine like terms, you're not changing the exponents. You're just adding or subtracting the coefficients in front because those tell you how many y squared t squared you have. And then finally, minus 8y cubed. Okay? Pretty cool stuff. All right, we can use the distributive property to multiply monomials by polynomials and solve real-world problems. So the theme for a school dance is solid gold. For one decoration, Kana is covering a trapezoid-shaped piece of poster board with metallic gold paper to look like a gold bar, a bar of gold. If the height of the poster board is 18 inches, how much metallic paper will Kana need in square inches? So basically got to get the area of this trapezoid. Okay, so the height is the distance between the two, the top and the bottom. So what we're going to first do is rewrite the formula for the area of a trapezoid in general. So the question is asking you to find the area of a trapezoid with a height of h and a base of h plus 1 and 2h plus 4. The area formula for a trapezoid is 1/2 the height times the sum of base 1 and base 2. So it's 1/2 the height times the sum of base 1, which is h plus 1 right here, and base 2, which is 2h plus 4. Now, inside the brackets, I can add the h plus 1 and the 2h plus 4, and that would give me 3h plus 5. Now I can distribute the 1/2 h and get 3/2 h squared plus 5/2 h. Now, I know that the height has to be 18 inches, so substitute 18 in, and you would get 531, and the units would be square inches, or you could write it as inches squared. This might be useful because if she has to find different trapezoids, maybe she needs to make a couple that are 18 inches, a couple that are 12 inches, a couple that are 24 inches high. Well, if you get the formula in terms of h, then you can just plug in 12, 18, 24, and whatever she needs. Also, it's useful to know the number of square inches she's going to need because usually you have to pay per square inch for something like this. All right, so here's one for you to try. Go ahead and pause the video. All right, we're back. Kachima is making triangular bandanas for dogs and cats in her pet club. The base of the bandana is the length of the collar with 4 inches added to each end to tie it on. The height of the collar, the height is 1/2 of the collar length. If Kachima's dog has a collar of 12 inches, how much fabric does she need in square inches? So we're talking about area. So the area of a triangle is 1/2 base times the height. So since they're talking about how long the collar is, the bandana length is the length of the collar with 4 inches added on to each side. So if this is the collar, they're going to add 4 inches to each side like this. All right. So the base of the triangle is going to have to be L plus 8. The height is equal to half the collar length. Okay, so if the base is L plus 8, so that would be 1/2 times the quantity L plus 8 times 1/2 L. So what you could do is put the 1/2 and the 1/2 L together to get 1/4 L in L plus 8, which would equal 1/4 L squared plus 2L. If I distribute there. So for part A, if L equals 12, then the area would be 1/4 times 12 squared plus 2 times 12. L squared is 144. So 1/4 of 144 is 36 plus 24 equals 60 square inches. For part B, if she has a 6-inch collar, the area is going to be 1/4 times 6 squared plus 2 times 6. 6 squared is 36 times 1/4 of that would be 9. Plus 12 gives us 21 inches squared there. Alrighty? Alright. Well, that's it for this video. Stay tuned for the second half, and we'll see you there.